With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So in this question, we are required to solve the differential equation dy by dx minus y is equals to cos x. So first of all, let us write this differential equation. It is dy by dx minus y equals to cos x. Now you must have noticed that this is exactly of the form dy by dx plus py equals to q. This is also known as linear differential equation. And if you compare these two, the value of p here is coming out to be minus 1 and the value of q is coming out to be cos x. So whenever we are given linear differential equation, what we do is we calculate integrating factor, which is given by e raised to the power integral of p dx. Okay, now here in this case p is minus 1, so we'll be writing e raised to the power integral of minus 1 dx. Now taking negative outside, you have integral dx, and integral dx is nothing but x itself, so it is e to the power minus x. This is the integrating factor. Now the solution of the linear differential equation comes out to be y into integrating factor is equals to integration of q into integrating factor plus constant. Now if you put these values here, so you have y into e raised to the power minus x equals to q was cos x, so an integrating factor minus x dx plus constant. Now let this particular integral be named as I. We'll be solving this separately. So I is equals to integration of cos x e raised to the power minus x dx. Now you can observe that this integral is the product of two functions, cos x and e raised to the power minus x. So we'll be using the by parts formula. So what is by parts formula? In this you are given an integral of product of two functions u, v, dx. What you do is u, this is your first function and this is v is second function. So you write first function integration of second minus integration of derivative of first into integration of second. Remember, this dx is for this integral and this dx is for this integral. So this is the formula for by parts. Now to conclude what will be the first function and what will be the v function, we will use the rule which is I late. Now I late, I stands for inverse trigonometric, L stands for logarithmic, A stands for algebraic, T stands for trigonometric, and E stands for exponential. Now here this trigonometry is coming at first, so this cos x of ours will become the first function and this e raised to the power minus x will become the second function. Now we can easily solve this integral now. So ei is equals to first function integration of second minus integration of derivative of first. Derivative of cos x is minus sin x into integration of second dx. If you solve it further, we all know that integration of e raised to the power minus x is e raised to the power minus x and the coefficient of x will come in the denominator. This will become plus integration sin x e raised to the power minus x divided by minus 1 dx. Now in the next step, let's take this minus on the upper side. So this will get you cos x e raised to the power minus x. This minus will come here. You will get minus sin x e raised to the power minus x dx. Now again, this is also coming out to be a by-part function. So we will be naming this as I1 and solving it separately. So I1 is integration sin x e raised to the power minus x dx. Again, this is trigonometric function, so this is considered to be the first function and this will be considered to be second function. Applying the same bipart rule here, so first function into integration of second dx, there is nothing here, and minus integration of derivative of first, derivative of sin s cos x into integration of second. Now in the next step, this is nothing. In the next step we can write again this integral will come out to be e raised to the power minus x and the coefficient will come in denominator, minus this will become cos x e raised to the power minus x minus 1 dx. This will become, I1 will become minus sin x e raised to the power minus x. This minus will become plus cos x e raised to the power minus x dx. Now you must have observed already that this is coming out as I, because initially the value of I that you took was cos x e raised to the power minus x integration, and here also you are getting the same. So you will be writing the value of I1 as I1 is equals to minus sin x e raised to the power minus x plus I. Now let's put this value of I1 in the equation of I. So the value of I was minus cos x e raised to the power minus x minus I1. So minus, in place of I1 you will be writing minus sin x e raised to the power minus x plus I. Okay, this will become minus cos x e raised to the power minus x, this will become plus sin x e raised to the power minus x, this will become minus I. Now take this I here, so this will become 2I equals to, if I take e raised to the power minus x common, this will give me sin x minus cos x. Taking this 2 on this side, so final integration is coming out to be e raised to the power minus x divided by 2 sin x minus cos x. Now I can put this value in the solution of my differential equation, which was initially coming out to be this. So let's write the final answer. So it was y into e raised to the power minus x equals to this integration, which is e raised to the power minus x divided by 2 sin x minus cos x plus an integration constant. This is the final solution to your problem. I hope you understood. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.